Please go ahead.
Okay. Am I audible, sir? Clearly?
Yeah.
Okay. Good afternoon to the galaxy of intellectuals on this beautiful day. I, Dr. Anita Khandizod from Symbiosis Skills and Professional University, School of Computer Science and Information Technology, Cyber Security, Pune. I welcome each and every one of you to brainstorming workshop on cloud computing. I am delighted to be here to chair this session on a cloud computing. It's a wonderful to be here. I consider it's a privilege for me to get an opportunity to interact with you. For today's workshop, we are honored to have with us an incredible lineup of distinguished speakers and experts who have made meaningful contributions in the field of cloud computing. Each one of them brings with them a wealth of knowledge and experience, making this workshop not only informative but also enriching experience. Without taking much more time, I have honor to introduce our first speaker, Dr. Neha Janu. Hello.
Yes, ma'am.
Okay. Yes. So our first speaker name it's Neha Janu. Ma'am currently working as an associate professor, Department of Computer Science and Engineering, Manipal University, Jaipur. Ma'am have a very good teaching experience. She already taught the subjects name machine learning, data structures and algorithm, design and analysis of algorithm, grid computing, subject software system design, distributed algorithm. Ma'am also performing mentor in database management system, July December 2021 for NPTEL. Also, ma'am granted one patent. The name of that patent which is IoT based, and the second patent also published by the Neha ma'am. The name of the patent it's an intelligent stock trend using machine learning and AI based Indian patent. So I welcome you, ma'am, and I request you to please share your knowledge to our audience. Thank you, ma'am. Please proceed.
Thank you, Anita ma'am, for this nice introduction. Wait a second. First, let me share the screen, please. Very good afternoon. This is Dr. Neha Janu, and today this video series we are going to understand regarding the cloud computing aspects according to the current requirements. As we know that everywhere, many times we hear the word like cloud computing. Someone is saying I'm using this cloud computing services, and someone is saying that we are going to purchase this cloud computing. So basically, what is this cloud computing? Why we are talking about this? So first of all, we will start with why cloud computing. Then we will discuss what are the different aspects of cloud computing, then how to create our own cloud server if we want to create. So initially we will discuss why cloud computing, what is the requirement of cloud computing. We can check that if anyone from us want to start a business, like you want to develop any application and anything else, if you want to start your own business. But for that, what we will have to do initially, we will have to do some planning for that. So what are those plannings? Means we will have to do the requirement analysis. And in requirement analysis, obviously we are talking about the developing of some applications and something else. Then there is some hardware requirements. There are some software requirements. If we are planning our own basis, then we will have to purchase first of all these resources which are required for that our particular business. First thing is this. Once if we have purchased all these resources, then next thing is who is going to maintain all this? Obviously, if we are starting our own business, then we are going to maintain it. So all of these things are require much more time of any owner which is going to start the new business. We can relate this with this also, that if you have any innovative idea or you have any right solution for the current market situations, but you don't have any uh, sufficient fund for that, that you can develop your own application, you can start your own business. In that also, it is dependent that you cannot start working on your own. So every time whenever we are discussing about the business and your own application development, all these things, the right owner who is having ideas, who want to start the business, is busy with all these plannings. From where I have to purchase these softwares, from where I will get the fund, from where I will, I will be maintaining all these things. Even if we talk about the companies or currently running organizations, if they want to start a new project and they are going to purchase some hardware like that is required for that project, then first of all they will have to do some market analysis. This is not directly they will go to the market and they will buy that hardware. No, first of all they will have to do that market analysis, according to their requirements, how many products are available in the market. If they get the list of the available products in the market, then they will have to find the suitable hardware according to their requirements. They will have to see the cost also, other they will have to see the performance also. Once they have finalized that hardware, then they will have to purchase that. For that they will have to spend some money. And once if they have purchased, what now they need to some space for keeping that hardware also. And once they have settled somewhere that hardware, now that particular organization or company will have to appoint some team for maintaining that hardware. All these things that company is doing only just for developing or only just for working on a single product. But how maximum time of that company is wasted in all these things. Initially they are planning for something and they are purchasing, they are doing some market analysis, and then they are spending money for that team also who is going to take care of that hardware. So these are the some challenges in the market for which we cannot perform efficiently if we want to work for something. It is challenge also for the organization also, they are facing like these challenges. All these things are happening when we are not talking about the cloud computing. Means prior to cloud computing, all these challenges are faced. But if we talk about the cloud computing, then it is everything is happening at the virtualization layer, and everything is happening as a virtualized mode. We need not to purchase anything hardware physically, we need to spare some time for all this inquiry, and we need not to appoint some extra staff. We are just only using someone else hardware, we are using someone else applications for developing our own ideas. Means now that owner of that business, owner of that organization have sufficient time for planning for everything. They need not to spend their time for all these things, they can only focus on their business. One more challenge is also there. Once if the company has purchased that hardware, then we know that technology is changing every time in the market. What if just that company have purchased that hardware and just after a few days new technology came in the market? Now that is older version, but it is the limitation of that company that cannot change that hardware because they spend for that. So this is also a big challenge. Even that company will have to use that hardware or resources which that purchased until they are not expired, because they spend for that. Even in market there are latest technologies, but after that also the company cannot update their hardware because they spend for that. They physically they bought that hardware and they kept somewhere at their company. Like this we can talk about mobile phones also. in every few months we are getting some software update for our mobile phones, and we update our software according to the requirement. But what if we ignore that update? Once we ignore, twice we, but sometime it will happen that it will stop supporting some new applications. So this is the reason we have to keep updated ourselves according to the new technologies in the market. So this is the reason that why cloud computing we are using. Every time we cannot purchase or buy the application resources. If all the resources we can take on rent, we can use, then it is okay. We can perform more efficiently. So this is the reason why we are using this cloud computing. Now, what happened? How this cloud computing was started? Initially, the companies like Amazon, Microsoft, some popular companies which were dealing with the data from the long back. What they started giving their services on rent for small business, small scale business applications. They started for giving their resources on rent for some time, for some duration, and they charged from those companies. So it was the benefit for those popular companies also, because they were getting money as a rent. But or it was benefit for the small businesses also, because they were getting resources on it. They need not to pay attention for all these things, maintenance, purchasing, all these things. They only need to focus on their businesses. So initially the cloud computing started. This was the concept of cloud computing that was started long back by these some popular companies. We are also using in day-to-day life, in our day-to-day life, some cloud computing platforms, cloud computing formats. Like we can take an example of taxi service also. If we need to go somewhere, then what if we want to go from one place to another? What if we have to purchase a new car for or new vehicle for going there? Or what if we are using cloud computing platform, then what we are doing? We are just taking a taxi, and we reach the destination, and we are paying only for that particular duration and time for what we have used that service. Now we need not to purchase that vehicle. We just book the taxi and we reach the destination. We will pay whatever the rent was there. So we are also in our day-to-day life, we are using many applications which are related to this cloud computing format. Basically, there are 5 essential characteristics of the cloud computing. First one is on-demand self-service. Yes, of course, as we have discussed the example of taxi service, it is on-demand service, means we can access this facility according to our demand, according to our requirement. And this is also a pay-per-use model, because how much we are going to use these services, we will have to pay for that only. We need not to purchase those resources. We will pay only for that, how much we have used that. So this is on-demand self-service. This is the first essential characteristics of the cloud computing. Next characteristics of cloud computing is broad network access. Yes, it is using cloud computing, we can access the broad network, because it is not our own network. We are using someone else in cloud computing. We are using someone else infrastructure, and we are paying for that. But we are not only only we are using that service. Maybe there are many customers who are using that same network. So this is the broad network which we can access using this cloud computing service. Third is the resource pooling. Yes, this is very cost effective, because using cloud computing, we can serve multiple customers at the same time. Customers are assigned and reassigned the resources according to their requirement dynamically. As we can take an example. Suppose I have purchased some cloud computing, I have purchased some space of 4 TB, and that was required for any my task. But it is not compulsory that every time I am using that complete space. It is possible that somehow I am using some less space, somehow I am using more space. So what is happening in cloud resource pooling facility characteristics of the cloud computing? What is happening that how much space I am using, the remaining space which is left is assigned to someone else, other customer, for some other purpose. Whenever I will require more space, then it will be reassigned to me. But through pooling system, multiple customers are using that same resource. So this is also the important characteristics of the cloud computing. Next characteristics is a rapid elasticity. Yes, whenever if we are using if we are not using cloud computing, in that case it is not compulsory, or that it is not feasible that every time when we require more resources we go and directly we can purchase. No, but if we are using cloud computing, in that case there is important characteristics of the cloud computing, that is rapid elasticity. Means we can use according more resources according our requirement. Suppose for 1 hour I need some more space for my some task, then for 1 hour I can request to the cloud provider that please assign me this much of more space for me 1 hour. And after that, as I have used that, then I can request for that now I am not using this space, then I will have to pay only for that 1 hour only, for that I have used that resources. Next characteristics is the measured service. Yes, sure. As we have discussed, this is pay per use model, because how much we are using, we will have to pay only for that. Not we need not to pay much for the complete whole system. So overall, we can say that we have seen that cloud computing is about utilizing the technology as a service. Means we are taking access according to our requirements, scaling up the resources, scaling back, and paying for what you are using. So only in cloud computing, we are using the technology as a service and technology on a rent. Next, we will be discussing about the cloud computing deployment model. Basically, these models are used if you want to deploy something of rented server on the internet. Whenever you want to deploy something on of the rented server, then we will be using these cloud computing models. Basically, there are three types of the cloud computing model. First one is public cloud, then private cloud, and hybrid. In public cloud, what is happening? This is open for everyone. Means there is a broad area network, and there are many customers who are sharing the same cloud. They are other customers are also using that. Means it is open for everyone. Multiple users are there, or they are sharing that public cloud. They are using that main service. Next one is private cloud. What is happening in this private cloud? Means it is not open for everyone. Means if I want to make my own private cloud, then what will I do? I will go to the cloud provider and I will ask him ki, these are my requirements, and according to this I want some public cloud. So what will be happening? There for that particular private cloud, I will be the owner now. That cloud provider is maintaining everything, but anybody else, other customer is not using that cloud. Only my organization, I'm using that cloud for my own purpose, for my own task. Next one is hybrid cloud. Means hybrid cloud is mix of public and private cloud, and in these days maximum companies, organizations are going for this hybrid cloud, because uh, uh, in public cloud, what is the drawback of public cloud? In case of public cloud, there is a security issue also, because it is publicly available for everyone. There are multiple customers who are using the same cloud, so there is a security issue. But in private clouds, what is happening? The owner is only one, only customer is only one, only that single person is using, single organization is using that cloud. In hybrid mode, what is happening? The organizations, what are they are doing? They are purchasing the hybrid cloud some of their sensitive data, what is if with that data is any security issue, for that particular data they are using hybrid mode, and some other applications which they want to get their data to the available to the public. For that purpose they are using public cloud. So in these days maximum companies are going for the hybrid cloud mode. For sensitive data they are using public cloud, and for publicly available data they are using public cloud. Next we will be discussing cloud computing service models. What are the different types of the cloud computing service model? Basically cloud computing service model, we can say it is a computer stack. We can it is a layered model. Basically why we can say that this is a stack or layered model, because all these layers, all these services are kept one another. So this is a computing stack. There are basically three types of the services. First one is infrastructure as a service, platform as a service, and software as a service. What is happening in case of infrastructure as a service means we are getting on rent the infrastructure. Means resources we are getting the complete, like we can computational resources we are getting. It can be also known as the hardware as a service. It is a computing infrastructure that we need not to make at our place, that is centralized managed by that cloud provider. As an example we can say that if you are going to take house on a rent, so that is also right example of this infrastructure as a service. Means a blank empty structure we are getting a house on a rent. Now we can plan according to us where we are going to put all our luggage and how we are going to manage that structure. We got an empty structure as a house, and now we will have to place our things in that house. Platform as service means it provides platform and environment to allow developers to make application service over the internet. We can take an example that if we want to host any party, so what if we are going to create the venue, then that is very cost effective, and there are many things, time also is also concern. Yes.
बीन्स है और क्या है, लौकी है और वो है बीन्स लौकी और पत्ता गोभी है.
If we are talking about the platform as a service,
50 की 2.5 किलो
you create if we are using the, but if we are using a cloud
Request all the
service,
participant to please keep your
मूली
keep
है
your mobile
भाजी नहीं
mobile on
मिली,
silent mode.
20 रुपए किलो.
Please keep your phone mobile on silent mode.
वो लेके आ गया वो जो होता है ना सोया चाप.
Anita ma'am,
Yes.
I think you also can mute at your end. I think so.
No, I am already mute, ma'am.
No, I'm not talking about that participant. I think you can also mute at your end.
Yes.
Yeah, I think so. Sorry for the disturbance. Just we were talking about the platform as a service, that just we are getting the platform as a service, and that is allowing the developers to make their application service according to their requirement. They are just only service provided. They are providing the hardware and software, their own infrastructure. Now it's user can easily develop their applications on them on their infrastructure. So we can take an example. We were just discussing about the hosting a party for someone. Then if we are going to purchase that venue, we are going to create venue that it is very cost effective and time effective also. So but if we take on rent that venue, then easily the things will be managed. We have paid for that. Yes, of course there are some limitations also, because it is a dependency on there is a dependency on the service provider, and we don't have control over the infrastructure, limited of flexibility. All these things are there, but even after platform as a service, if we are taking on a rent some services, that is better for other than creating those resources. Software as a service, is a way of delivering services and application over the internet. Rather than purchasing and installing software, we are directly using on the internet according to our requirements or as according to whatever we want to develop with those. So next one is, as we have discussed, why cloud computing, what is cloud computing, what are the different cloud types of the cloud computing, what are the different models. Next is how to build our own cloud infrastructure. How, if we want to create our own infrastructure, and how to build this cloud infrastructure. Very first thing that is with making the cloud infrastructure is infrastructure should meet essential cloud characteristics, which we have discussed in its on-demand service, all these things, resource pooling, all these essential characteristics should be met by the infrastructure. Then only you can create that as a cloud. So there are various steps which are involved in the building the cloud infrastructure. Very first thing is understand your own infrastructure. Okay, what resources you are having. Sorry. Next one is virtualization of initially, if we are having some different resources, multiple resources can be combined at one place, and from the next step is virtualize your infrastructure. Means we will have to apply some kind of virtualization steps on that. And last is deployment services and management tools. These are used for automating the services, metered service. All these are handled by this deploy service management tools. So these are the steps for developing initially at the existing infrastructure. When we are combining all the existing infrastructure, in that phase, every entity is created separately. But whenever there is a data request from the user, from the customer, they work jointly as a single characteristics. Again, they are maintained separately, but whenever there is a request, they work as a single entity for providing the services to the customer. So this is a journey to the cloud. First of all, initially, we start with the classic data center. What is the classic data center? This is physical resource, physical entity containing IT resources. And also we can say that it is a collection of data. It is a place where we can store data or applications. So these are the existing infrastructure. Next step is virtualized data center. What is it? When we apply virtualization techniques on this classic data center, then we go to the virtualized data center, and then last phase is the cloud computing, through which we can provide the services to the users. So what is very first, what is classic data center? As we have discussed, this is a physical entity containing IT resources. That can be included compute, network, and storage. So there are basically 5 core elements of classic data center. Very first is application. Next one is database management system, compute, storage, and network. Application is a computer program that provides the logic for computing operations. And DBMS, as we all know, I think DBMS provide the structured way to store the data. With whatever data we are having, how we are going to organize that data in tables, in form of tables. Compute is a physical computing machine that runs operating system up communication between client and the compute system. Whenever any client is requesting for data, then using this network, we can the request is communicated to that your system, and again it is the communication. It provides communication between the user and the requirement. These are the key requirements of the classic data center. Whenever we are using, we are going to start building our own cloud computing application, then initially we will have to deal with our classic data center. And classic data centers, these are the requirements which any availability, performance, flexibility, scalability, security, data integrity, all these are the key requirements which any classic data center should satisfy. Otherwise, what is happening? There are so many cloud applications in the market. If these characteristics are not available in your that classic data center on which you are going to perform virtualization, so nobody is going to your cloud service. So first of all, we will have to ensure that all these key requirements are fulfilled by our classic data center. Thank you, ma'am. If any, Anita ma'am? Anita ma'am, am I audible?
Yes.
Yes, ma'am. This all this was from my side. If any questions are there, then we can handle it.
Yes, I request all the participants, if you have any questions, so please ask.
Madam, cloud computing and cloud interfacing is both are same. Is there any trial version or limited days with at free of cost for a students project, madam?
Hello, Neha ma'am. Neha ma'am, are you there? Neha ma'am. So I request a participant, can you put your questions in chat box, sir, please? That might be possibility some network issue from Neha ma'am side. Hello, I'm audible.
Yes, ma'am, you are audible, but the participant has to respond.
Yes, he already cloud interface. Okay.
Maybe
Okay,
we
sir.
go further. Yeah.
Yes, sir. Yes, sir. Thank you to Neha ma'am for enlightening talk now. And let us welcome our next speaker. Moving further, it's my immense pleasure to introduce our next speaker, Dr. Sharvari C. Tamane ma'am. She recently she's working as a professor and head from MGM University Aurangabad, Maharashtra, Department of Information and Communication Technology. Ma'am having more than 25 years of teaching experience. Ma'am research area specifically include cloud computing and security, big data, neural network, fuzzy logic. Ma'am has published more than 70 research papers, obtained 2 patents, Australian patents, and 3 Indian patents. Also, ma'am having 3 copyrights in the Copyright Office of Government of India. Ma'am successfully published 3 edited books, 10 chapters with IGI Global and Springers, and a textbook on a data structures using C. She has successfully guided 3 PhD students, currently gaining 8 research scholar under Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and MGM University, Aurangabad. Ma'am having a membership like CSI, ISTE, IETE, IEEE. Ma'am also received Best HOD of the Year at the CSI Tech Next India 2019, awarded by Academia. Ma'am also published, edited book, the book title Big Data Analytics for Smart and Connected Cities. Again, Ma'am, we have a privilege to have with us today. Now, may I request Dr. Tamane ma'am to share her thoughts. Over to you, ma'am. Thank you.
Yeah. Am I audible?
Yes, ma'am.
Yeah. And my screen is also visible, I think.
Yes, ma'am. Yes.
Yeah. So thank you so much, ma'am, for the nice introduction. And good afternoon, everyone. Thank you, World Resources Webinars, for giving me the opportunity to speak today. My topic for the presentation is cloud computing services. And these are the contents. So where we are going to see understanding cloud computing, cloud service models, cloud deployment models, popular cloud service providers, advantages, future trends, challenges, and conclusion. So cloud computing, as Neha madam has also explained, so it is a technology that allows users to access and use computing resources such as servers, storage, databases, networking, software over the internet, and therefore it is called as the cloud. So there are different key characteristics. On-demand self-service, like users can provision and manage resources as needed without human intervention. And next characteristics can be broad network access, where it is accessible over the network through standard mechanisms. In resource pooling, we can say that resources are shared among multiple users with different physical and virtual resources dynamically assigned and reassigned. In case of rapid elasticity, we can say that resources can be rapidly and elastically provisioned and released. Then in measured services, so usage is actually monitored, controlled, or reported, providing transparency for both, that is the provider and the consumer. So these are the very important key characteristics of cloud computing. And regarding the evolution, in early days, so we can say that the computer or the computing power was concentrated in mainframes, and limiting accessibility and flexibility was there. So it was a centralized computing. Then the client server model came in 1980s and 1990s, so which moved towards the distributed computing with client server models. Later on, the internet boom was there in late 90s and early 2000s. So the rise of the internet led to increased connectivity, setting the stage for the cloud computing. Then came the utility computing in mid 2000s, where the concepts of utility computing emerged, where computing resources were provided as a service. Then later came the Amazon Web Services and the commercialization in 2006. So AWS launched the offering various cloud services on a pay-as-you-go model, where the marking a significant milestone over there. And in late 2000 and 2010s, so more providers entered the market, offering a variety of services, and businesses started migrating to the cloud for scalability, flexibility, and cost of efficiency. So nowadays, so modern IT needs are again the scalability, cost efficiency, flexibility, then the innovation and agility is also there. So in these all characteristics which we are needing, so cloud allows for easy scalability, where it can accommodate fluctuating workloads. We can also go for that pay-as-you-go models to reduce the upfront costs and provide the cost-effective solutions. In case of flexibility and accessibility, remote access to resources enables the global collaboration and easy data access. And therefore, the cloud service facilitates the rapid development, experimentation, and innovation. So cloud services models are actually divided into three major categories, where we can say infrastructure as a service. It is also called as IaaS, platform as a service, PaaS, and software as a service, SaaS. So we'll see one by one. IaaS is a cloud computing model that provides virtualized computing resources over the internet. It includes virtual machines, storage, and networking resources. So regarding the overview of this, so users can rent virtualized hardware resources such as servers, storage, and networking components. Then they are offered flexibility and scalability without the need for physical hardware ownership. And users then can have the control over the operating systems, then the applications and configurations they have. And therefore, it is more suitable for the users who require more control and customization of the infrastructure. There are different types of users. So catering the different needs of the different users, actually there are different target users for this. Like we can say IT administrators are there, or businesses with specific infrastructure requirements are there. And therefore the need for each type of these users are different. So where we can say that the AS allows organizations to quickly provision virtual machines and other resources for development and testing purposes without the need for physical hardware. And then businesses can with varying web traffic can leverage the AS to scale their hosting infrastructure up or down based on the demand and ensuring the optimal performances. It can also be used for, they are also providing different scalable or reliable storage solutions, making it ideal for data backup, archival, and storage intensive applications. It can be also used for high performance computing, like such as the scientific simulations, complex data analytics, by providing more powerful computing resources. There are different benefits of this AS: flexibility and control, where users have full control over the infrastructure, allowing the customization of operating system applications and configurations according to specific needs. Then it is also cost effective, where AS can eliminate the need for upfront capital investments in physical hardware. Users only need to pay for the resources they consume, and therefore they can make it cost effective. In terms of scalability, as it is having the this facility to scale up or scale down different requirements depending upon the their applications to adapt to changing workloads without the need for extensive manual intervention. And therefore, the AS providers, they often have data centers in multiple regions, and they allow the organizations to deploy resources globally for improved performance and redundancy. In case of PaaS, platform as a service, a cloud computing model can offer a platform allowing customers to develop, run, and manage applications without dealing with the underlying infrastructure. It provides a platform with tools and services for application development. It includes databases, development frameworks, and middleware. Yeah, any issue?
No, ma'am, please go ahead.
Yeah. And the users can focus on application development while the cloud provider manages the underlying infrastructure. They can streamline the development process. They can reduce the complexity of managing hardware and software components. And therefore, it is ideal for developers and organizations looking to accelerate application development and deployment process. So the target users for PaaS are the different developers and application focused teams. So where PaaS can streamline the development process by providing tools, frameworks, middleware. It also allows developers to focus on coding without managing the underlying infrastructure. And PaaS platforms, they often offer the features specifically designed for mobile app development, making it easier for developers to create and deploy applications for various devices. There are also the integration services available, which can be used for different applications, which they can facilitate for communication between different components of a software ecosystem. It also supports the development of applications based on microservice architectures, where applications are composed of small independent services. There are different benefits, like as there is rapid development and deployment. So PaaS accelerates the application development cycle, reducing the time to market by providing pre-built components and automating many development tasks. It can also save the cost by handling the different infrastructure management, resulting in reduced operational costs. PaaS platforms automatically scale based on the demand by eliminating the need for manual adjustments, and therefore this flexibility allows the efficient resource utilization. So these are the various benefits we can say. Then comes the software as a service, where SaaS is a cloud computing model that delivers software applications over the internet on a subscription basis, and users access applications through a web browser. Applications are centrally hosted and managed by the cloud provider, requiring no installation on user's device. Users can also access the software through a web browser, typically with a pay-as-you-go pricing model, and they eliminate the need for software maintenance, updates, and hardware infrastructure management. And therefore, it is ideal for end users seeking ready-to-use applications without the burden of installation or maintenance. It can also cater the different user needs for users like the business seeking ready-to-use applications. For example, the different use cases for this are email services, office productivity tools, customer relationship management. In case of customer relationship management, SaaS CRM solutions such as Salesforce or help businesses to manage the customer relationships, sales, and marketing activities. In case of office productivity tools, SaaS applications like Microsoft 365 and Google Workspace provide the cloud-based offices, the productivity tools, including word accessing or spreadsheet or collaborative softwares. And as everyone uses emails, so SaaS email services like Gmail and communication tools such as Slack and Microsoft Teams facilitate efficient communication and collaboration with organizations. It also helps for the QuickBooks Online and Zero offer cloud-based financial management for businesses. There are different benefits of this, as there is no software maintenance and automatic updates are there. Accessibility from any device with an internet connection is available. So they are providing different benefits like accessibility and convenience. Like users can access SaaS applications from any device with an internet connection, promoting remote work and flexibility. SaaS providers handle software updates and maintenance, ensuring users always have access to latest features and security patches without manual intervention. It is also cost effective because the software licenses, hardware infrastructure, and ongoing maintenance, they are not need to do all these things, and therefore they can save the cost. And again, the scalability facility is also there, so that to accommodate the growing or fluctuating user demands without requiring additional hardware or software investments. Next, we have the cloud deployment models. Cloud deployment models refer to the ways in which cloud computing services and resources are made available to users. There are several deployment models, each with its own characteristics and use cases. Three major cloud deployment models are public cloud, private cloud, and the hybrid cloud. In case of public cloud, the public cloud is a cloud computing model where cloud services are provided by third-party vendors over the internet, and these services are made available to the general public, and multiple organizations or individuals share the same infrastructures. They provide accessibility, which is available to anyone who is having the internet connection. It is cost efficient because the infrastructure is shared with by saving the cost for the users. Then scalability, it provides providers can scale the resources dynamically based on their demands. And there are different use cases for this, like web-based email services are there. Then file storage and sharing platforms are also available, like Dropbox or Google Drive. And development and testing environments are also available. In case of private cloud, the private cloud is a cloud computing model where cloud services are provisioned for exclusive use by a single organization. It can be hosted on premises or a third-party provider. And it has various characteristics like isolation, customization, and compliance. In case of isolation, resources are dedicated to a single organization, providing enhanced control and security. Organizations have the flexibility to customize the cloud infrastructure to meet their specific requirements, and suitable for industries with strict regulatory and compliance requirements. So these are the main characteristics of the private cloud. And the different use cases for this are government agencies handling sensitive data, enterprise with strict security and compliance needs, and different organizations with legacy applications that require a private environment. So like this, different use cases are there. And in case of hybrid cloud, it is a cloud computing model that combines elements of both public and private clouds. It allows data and applications to be shared between them. And it has then the mixed characteristics like flexibility, where it enables a balance between the benefits of public and private clouds. And the organizations can use public cloud resources for scalability while keeping sensitive data in a private cloud. So both can be, it is facilitating. Then in case of data portability, applications and data can move between public and private clouds as and when needed. And there are different use cases for this, like businesses with dynamic workloads that require scalability from public clouds, applications with varying securing and compliance requirements, and data backup and disaster recovery strategies that involve public and private clouds. So these deployment models, they are offering the organizations flexibility in choosing the environment that best aligns with their specific needs, considering the factors such as security, scalability, and compliance requirements. So the choice of the deployment model depends upon the nature of the applications, data sensitivity, and organizational preferences. There are different cloud providers depending upon what type of cloud service we are hiring, like IaaS, PaaS, or SaaS. So regarding infrastructure as a service, the providers are Amazon Web Services, where they offer a comprehensive set of IaaS solutions, which includes the virtual servers like EC2, then storage, S3, and networking services. There are also different providers like Microsoft Azure. So it provides range of IaaS offerings such as virtual machines, storage, networking solutions, or integrated with different Microsoft's ecosystem. There is also Google Cloud Platform, which offers virtual machines, scalable storage, and networking services. Then IBM Cloud Infrastructure is also there, which provides the virtual servers, storage options, and network services catering to the enterprise level requirements. And one more is there like Oracle Cloud Infrastructure, which offers our services, which includes the compute instances, then storage, networking solutions with a focus on enterprise applications. For PaaS, platform as a service, there are different providers like Heroku, which is a cloud platform that simplifies application deployment and management, supporting multiple programming languages. Then Google App Engine, which fully manage PaaS offerings by Google, which enables developers to build and deploy applications without managing the underlying infrastructure. Then Microsoft Azure is also there, which facilitates the development, deployment, and scaling of web and mobile applications with different tools. Then Red Hat OpenShift is also there. This automates the deployment, scaling, and management. Then Salesforce Lighting Platform is also there, which is formerly known as Force.com. It is the solution that enables the development and deployment of custom applications on the Salesforce platform. In case of SaaS, there are again the different providers like Microsoft 365. There is a suite of SaaS applications, which is Word, Excel, PowerPoint, and collaboration tools like Microsoft Teams is also there. Then Salesforce, which is a cloud-based SaaS platform offering customer relationship management solutions for sales, service, and marketing. Then we have Google Workspace. They provide Gmails or the Google Docs, Sheets, then the collaborative tools for businesses depending upon their requirement. Then also Zoom provider is there, which is a popular video conferencing SaaS application that allows the users to conduct online meetings, webinars, and virtual conferences like we are currently having. Then Adobe Creative Cloud is also there, a SaaS offering that provides access to Adobe's creative software suite, includes Photoshop, Illustrator, and Premiere Pro. So like this, there are some more providers also available. Depending upon our requirement, we may use it. Then there are different advantages of cloud computing, like it is saving the costs, then it is providing scalability, flexibility, and collaboration. In case of cost savings, as we have already seen, the reduced capital expenses, because the traditional IT infrastructure, they require the significant upfront capital investments in hardware, software, and the other facilities. But the cloud computing eliminates or reduces these initial costs and allows the businesses to access computing resources without large capital expenses. And as we also have the pay-as-you-go models, where the cloud computing operates this service, where users can pay only for the resources they consume. And this cost structure provides flexibility and cost savings, as organizations can scale their usage up or down based on the actual needs. In case of scalability, it has the ability to scale the resources depending upon, again, their needs. So it allows businesses to scale their computing resources up or down, and the elasticity ensures the organizations can handle varying workloads without the need for over provisioning, providing the cost efficiency and the optimal performance. Sometimes the cloud services offer automatic scaling also, where resources are adjusted dynamically based on the real-time requirements. Then comes the flexibility, where the cloud service provides the flexibility by offering a wide range of computing resources, which includes the virtual machines, storage, databases, and specialized services. Users can choose their service that best suit their requirements. Then the geographic flexibility, where the cloud computing allows users to deploy resources in multiple geographical regions and provides accessibility to all. So this is again the crucial requirement of the business, where they can utilize this. And in case of collaboration, Cloud-based tools and services enhances collaboration by enabling real-time access to shared documents, communication platforms, and collaborative applications. And team members can work simultaneously on projects from different locations, fostering teamwork and productivity. Then this data is also available in centralized data storage, so they can everyone can access it. And again, the authorized users may have the access, only have the access from different locations. And so this ensures the teams, they can access the latest versions of the documents and reduces the version control issues, if any. Then the integrated communication tools are also there, where the cloud-based communication tools such as video conferencing and messaging platforms allows teams to connect seamlessly. So these are the different advantages of cloud computing. We only see the future trends and then we'll stop. In case of future trends, the edge computing in cloud architectures are there. So where it involves processing data closer to source of data generation, and it reduces then the latency and improves the performance by processing data at or near the edge of the network rather than relying on a centralized cloud server. The second trend, we can say that the serverless paradigm and its impact. So where the serverless computing, also known as the function as a service, allows the developers to run individual functions or pieces of code in response to events without managing the underlying server infrastructure. AI in the cloud. So the integration of artificial intelligence in cloud services involves leveraging cloud platforms to deploy, manage, and scale AI and machine learning models. Then comes the hybrid and multi-cloud architectures, where the hybrid cloud architecture involves a combination of on-premises and public cloud services. It allows the organizations to maintain certain workloads on premises while leveraging the scalability and flexibility of public cloud resources. In quantum computing, it involves using the principles of quantum mechanics to perform computations, and the cloud providers are exploring different ways to make quantum computing resources available to users as part of their cloud services. And we can also make use of blockchain integration in cloud services. Like blockchain is a distributed and decentralized ledger technology that provides a secure and transparent way to record transactions. Cloud providers are exploring ways to integrate blockchain services into their offerings. I have this challenges and this slide also, but I think Neha madam has taken it in a detail. So I'll just skip this and conclude this. I have already covered the different key aspects of this cloud computing and showcasing its transformative impact on the IT landscape. And so lastly, I'll just say that the cloud computing has become a cornerstone of modern IT infrastructure, offering unprecedented opportunities for innovation, efficiency, and collaboration. As the technology continues to evolve, organizations can harness the transformative power of the cloud to drive their digital initiatives and stay competitive in an ever-changing business landscape. So, thank you from my side.
Yes, thank you so much, ma'am. I request to audience, if you have any question, please unmute yourself. Yes, from audience. I think we have one questions in chat box. Sharvari ma'am. What are the security threats in public cloud?
Am I audible, madam?
Yes, ma'am. Yes, ma'am.
Yeah. So, security threat in public cloud is data breaches, ma'am. So, due to unauthorized access, which can result from misconfigured security settings, inadequate access controls. So, because of this, the other threats also are there, and so there is a possibility of account hijacking or insider threats. So, like those different threats are there.
Yes, ma'am. Yes, ma'am. Thank you so much, ma'am, for your valuable information. It will definitely help us in future. So now, moving further, I again, it's my immense pleasure to introduce our next speaker, Dr. Saifullah. Sir, currently working as an assistant professor, University of Hyderabad. Sir, work more than 2 years of TNET Group, Triple IT Madras, NMS Work Software Limited, Chennai as a project officer and lead engineer, and a part of the development team, Signet, and integrated network management system. Sir also work as a project and technical leader in the development team of networking products, Tata Elxsi, Bangalore for an year. Sir also worked as a senior software engineer in the team of server load balancer for the data science in Cisco Systems, Indian Private Limited, Bangalore for more than 7 years. Sir, also having a members of different review committee like Triple IT AIM 2002 International Conference on Integrated Network Management, USA, International Symposium on Performance Evaluations of Computer and Telecommunication System, Andhra Pradesh, India. So I request Dr. Saifullah sir to please share your valuable knowledge to us, sir. Thank you. Over to you, sir. Please.
Thank you, madam. Thanks for the nice introduction. And thanks to the WRW, World Resources webinar team for giving me this opportunity. Is my voice audible?
Yes, sir. Yes. Please proceed. Yes, sir.
Okay, yeah, sure. Is my slide visible?
Yes, sir.
Thank you. Yeah, as Professor Sharvari madam talked about edge computing in the future trends, you might have seen it as it is one of the future trends, and that edge computing is also called fog computing. So we will see cloud computing and fog computing. Fog computing is in the context of IoT. So the outline of my presentation is I'll give cloud computing for IoT or the benefits of cloud computing for IoT, and then we will try to compare cloud computing and fog computing. For that, to go into the details of fog computing, we need to look into the IoT. We look at IoT applications and IoT components or the IoT implementations, and then if time permits, we will take a look at how SDN is benefiting to cloud computing. And I'll conclude. So benefits of cloud computing for IoT are many. They are scalability, flexibility, cost effectiveness, and security. Scalability, as the name is self-explanatory, cloud services can handle large amounts of data from many devices and adjust to changing demands. So because of the cloud computing usage in the IoT, it improves the scalability and flexibility. Cloud services can support different types of data and services, devices, and provide various options for data management and analysis. So cloud gives flexibility to IoT and cost effectiveness. Cloud services can reduce the need for investing in hardware, software, and maintenance. As it is already discussed, it is easy to understand. And security, cloud services can provide encryption, authentication, and backup for data protection and privacy. So because of the cloud computing, IoT gets these benefits. So let us compare the cloud and fog features. So this is the context of the cloud computing, as the internet is in the middle and the cloud users, the end users, they are in the general labs connected. I mean, if it is an organization, and that LAN may need to be connected to a switch and switch to the router, edge router, and router to the network from there. So the actual cloud service providers. So they are typically in the data centers. So this is the context of the cloud computing. I mean, we are trying to compare the fog computing or the edge computing to the cloud service, cloud computing. So the cloud computing element, as the previous presenters, professors have already explained. So no need to go into more details. So you have seen all the essential characteristics of the cloud and service models, 5 essential characteristics, and 3 service models, SaaS, PaaS, SaaS, and deploy models, public, private, hybrid, and community. So these are the cloud computing elements which you have already seen in the previous presentations. So no need to explain more. And these are the 3 models, SaaS and PaaS and IaaS. Here you can clearly see which is visible to the subscriber and which is not visible to the subscriber. Cloud application software, this is provided by the cloud, but visible only to the subscriber. This is the SaaS model. So here cloud platform is only visible to the provider. Infrastructure is also visible to the provider. Whereas in PaaS, the cloud application software is developed by the subscriber itself or the user, but the platform is visible to the subscriber. And the cloud infrastructure is visible to the provider only. Whereas in the IaaS, cloud application software is developed by the subscriber, cloud platform is visible to the subscriber, and also cloud infrastructure is visible to the subscriber. This is just to compare the service models, and these are already explained. What is SaaS, PaaS, and IaaS, and also the infrastructure model. And these are also deployment models are also explained. Public cloud, private cloud, and community cloud, and also hybrid cloud. So these are the 4 types of deployment models of cloud computing. And then let us see more about fog computing. It is I mean, in the other name is edge computing. Little, I mean, both are almost same. So the fog computing is about processing at the edge computing level, means very low at the level. We will see diagrammatically also what is low and what is high. So edge computing level is sometimes referred to as fog computing. Fog computing and fog services are expected to be distinguishing characteristic of IoT. We will see more. Figure in the coming slide illustrates the concept. Fog computing represents an opposite trend in modern networking from cloud computing. Because cloud computing is at the center level and fog computing is in the bottom level, we will see what is the difference and how it works. So with cloud computing, massive centralized storage processing resources are made available to distributed customers over cloud networking facilities to a relatively small number of users. So here, the users are subscribing to the services, cloud computing services, whereas with fog computing, massive numbers of individual smart objects are interconnected with fog networking facilities that provide processing and storage resources close to the edge devices in the IoT. So the edge devices talks to the fog devices, fog services, takes the fog services, and this is about smart objects. So fog computing is for the smart objects. We'll see what are those smart objects also. We'll just take a small introduction. Fog computing addresses the challenges raised by the activity of thousand or millions of smart devices, including security, privacy, network capacity constraints, and latency requirements. So the term fog computing is inspired by the fact that fog tends to hover low to the ground, whereas clouds are high in the sky. Yeah, we can easily understand it. So take a look at this diagram. So let us go from the bottom. This is about the fog computing, where it is. So in the IoT layers, the bottom is the smart things and network. So this includes Bluetooth, Wi-Fi, wired millisecond response time. So these sensors and things, there can be millions of devices. So these sensors, any sensor, I mean, like our camera is also a sensor, our thermometer, our AC sensors, whatever we have, those are the examples. So whatever we have in the mobiles, they are also sensors. So above this layer, the fog comes, the edge computing, fog network. So this contains the more wireless 3G or 4G or 5G, long-term evolution or Wi-Fi, distributed intelligence, real-time response time. So here the response time is in milliseconds, and here it comes in the real time it comes. So here the devices are tens of thousands of devices. Above it is the core networking devices like the routers, IP, MPLS, security, QoS, QoE driven, QoS quality of service, QoE quality of experience driven, response time devices. Here thousands of devices. Whereas the next level is the cloud computing. That is the data center or the cloud computing, the high. That is why we are say in the sky like cloud computing, whereas lower is the fog computing. Because clouds are little high, fog comes little low, below that. So the data center and cloud. So here Ethernet transactional response time. So the network management services are there and the applications. Here hundreds of devices are there. So this is what the comparison between the fog and cloud, and we are going more. So let us take more comparison. The cloud location of processing or storage resources is in the center place in the network, whereas fog goes to the edge. Edge means it goes to the near to the sensors or things, smart things. We will see what are those smart things. Latency, the cloud latency is high and fog latency is low. That is why fog is required. Access is cloud is fixed access, that is wired access or the wireless, whereas fog gives mainly wireless. Support for mobility, cloud has no mobility support, whereas fog has mobility support. Control, cloud has centralized or hierarchical control, full control is there, whereas fog has distributed and hierarchical partial control. We will see more. Service access through core devices, here at the edge or on handle devices. Availability, cloud is high availability, 99.99 because it is in the data center. Here it is highly volatile because of the wireless services, highly redundant, that is why because of the volatile nature. Number of users or devices, in the cloud they are tens of hundreds of millions, whereas in fog tens of billions because of the near to the smart things. Main content generator, here in the cloud it is human, whereas in the fog it is devices or the sensors. Content generation place, it is in the central location. Fog can be anywhere. Mostly it is near to the smart devices. Content consumption, it is in the end device. It can be in any device, anywhere. Software virtual infrastructure, central enterprise servers, here user devices are the infrastructure. So let us take little introduction about the IoT, so that we know what is the smart things or things what we are talking about, the sensors and all that, so that we'll get little introduction. We'll not go more into that. So as IoT is Internet of Things, it is a term that refers to the expanding interconnection of smart devices ranging from appliances to tiny sensors. We'll see what are those sensors. So this IoT adds a new dimension. As we can see, the network is always time, anytime, means daytime or nighttime, anytime is the network. I mean, the wired connection, it goes anytime is the dimension. Whereas wireless adds any place connection, on the move, outdoor, indoor, at the computer. So IoT adds the new dimension, that is anything connection between computers, human to human, not using computer because of the sensors, human to thing and using generic equipment, or thing to thing is also possible. That is using the IoT. This is the new dimension added by the IoT, and that is where the sensors and things comes and the need of the fog computing. And IoT applications are many, as we know already. So there are applications on home, cities, environment, energy systems, retail, logistics, industry, agriculture, healthcare, and many. These are easy to understand because in the home automation and in the city, smart city applications, and in environment, energy, and retail applications, and logistic applications. As these are easy to understand, I am going faster. So fleet tracking, ship monitoring. If any one of you are interested, we can go more into details. So agricultural applications of IoT are many. Smart irrigation, greenhouse control, in industry, machine diagnostics, indoor air quality monitoring. These are few, and there are many other applications also. So let us see IoT components, what we were talking about things. Thing is an object of the physical world, physical things of are the information world, virtual things, which is capable of being identified and integrated into communication networks. But this thing needs to have two characteristics. One is it needs to be identified and it can be integrated. It needs to have the ability to be integrated into communication networks. These two characteristics needs to have a thing needs to have these two characteristics. So that is the thing what we are talking about. A device is in a piece of equipment with the mandatory capabilities of communication and the optional capabilities of sensing, actuation, data capture, data storage, data processing, many. So sensors, a sensor measures some parameter of physical, chemical, biological entity and delivers an electronic signal. In both cases, the sensor output is typically input to a microcontroller or management element. And this is how the picture looks like, the interfaces for sensor and actuators, where the sensors give the inputs and the the control monitors it, analyze it, plan it, and execution, the actuator takes place. The actuator receives an electronic signal from a controller and responds to by interfacing with the environment to produce an effect on some parameter of a physical, chemical, or biological entity. This is what the description of the actuator. And embedded systems, it is easy to understand. And this is the possible organization of embedded system.
Sir, sorry for interrupt.
Yeah.
Sir, your screen is not moving. Can you please check?
Oh, is it?
It's not moving, sir.
Oh, from the beginning.
Yes.
Oh, I'm sorry. I'm really sorry for that. Is it moving now?
Yes, sir. Yes, sir. No, now you are at slide number 7, right?
Please read out the name of the slide. Microprocessors.
Cloud computing context. It's
is
one
it?
figure.
Oh, okay, okay. Oh, I mean, I am in the no. Okay, there is something. Let me actually.
I think this point also.
Yeah. So it has actually gone to. Is it visible now?
Yes, sir, visible and moving also.
Okay. Oh, yeah. I mean, the full screen has got the problem. Yeah.
Okay.
Anyway, it is coming to the point. These are about the microcontrollers. No need to go more into the microcontrollers. Microcontroller chip makes a substantially different use of logic space available. And this is the typical microcontroller chip in elements. Transceiver device. I'll not go more into this because I want to show the where the fog computing comes into the IoT. So let us look at Internet of Things architecture and implementation. There are two reference models of IoT, ITUT reference model and World Forum IoT reference model. There are two reference models and we will see what they are. IoT implementations are two, that also you will see. IoT VT implementation and IoT IO bridge implementation. So this IoT architecture, there are two reference models we said. This is one of the reference models where it talks about separately management capabilities and here. But the World Forum reference model, which is mostly used, it clearly talks about the fog computing or the edge computing. If you see from the bottom, the physical devices, what we talked about, the things and sensors or actuators, controllers, they come into this layer 1. And the next layer is the connectivity, the communication or the processing units. And the next level is the fog computing. This is what we have been talking about, the edge of the fog computing, data center analysis and the transformation. And the above are the data accumulation, the data storage and data abstraction, aggregation, access, and application. There are application layer, reporting, analytics, control come into this layer. And the above layer is the last layer, collaboration and processes, where it involves people and business processes. So this is where the edge computing plays in. Yeah. One more diagrammatic explanation. Old forum reference model has this explanation also. So where it talks about the devices in the lower level, network connectivity in the next level, edge computing is there, that is the fog computing. The above layer has already explained in the conceptual diagram. And this is things diagram, where it gives the examples of the devices. So the device storage, where the data storage is there, and abstraction, the software abstractions, applications, and the actual business control. Yeah, this is a brief introduction about the fog computing. And IoT implementation, if you go, it will take more time. So it has 2 IoT implementations. And that is what I wanted to show, where the fog computing and edge computing comes into IoT. So IoT is the open source implementation of the IoT. And constrained devices are the devices which have constraint, as the name is self-explanatory, constraint on the power. Yeah, any questions on this comparison of cloud computing and the fog computing?
Yes, any question?
Because I have other
Yes, sir.
We can go further.
Okay, sir. Okay. So thank you so much, sir, for discussing comparison of cloud and fog features. Your valuable word and knowledge always helpful, definitely help us in future. So moving further, it's again immense pleasure to introduce our next speaker, Dr. Pankaj Dadheech. Sir, recently working as a professor and deputy head from Swami Keshavananda Institute of Technology, Jaipur. Sir is graduated in computer science, also completed MTech and PhD in computer science and engineering. Sir also, hello, I'm audible?
Yes, ma'am.
Yes, sir. Subject expertise in Internet of Things, big data analytics, cloud computing, information system, security, data mining, warehousing, compiler construction, distributed system, grid computing, software system designing, advanced data management, parallel and distributed computing. Sir, also the PhD research supervisor in computer science and engineering at SKIT Jaipur. Sir published more than 25 research papers and also the members of different research community. The fundamentals of the big data for he's done his doctorate in fundamentals of the big data. With this introductions, I request to Dr. Pankaj sir, please guide you our audience and please share your valuable knowledge, sir. Thank you so much. Please proceed, sir. Thank you.
Yes, but now my slides are visible
Yes, sir. Yes, sir.
and moving also.
Yes, sir.
Okay. So thank you for introduction. So my presentation topic is how cloud computing is changing IT. So the agenda is what is cloud computing, enabling cloud computing, impact on applications, and then projects. So why cloud computing? So you can see with all of the interest surrounding cloud, it is helpful to understand what is driving this need to change. Each IT organization has its own unique drivers, but they generally fall into some general categories like cost, availability, time to market, etc. So there are pressures outside IT from the organization highest level executives who are looking for more flexibility, doing more with less cost, and using information as a competitive advantage. IT organization want to respond by transforming IT into something with greater business agility. So the IT challenges which you can see uh, have made the organization thinks about the cloud computing model to provide better service to their customers, like globalization, ag- aging data centers, storage growth, application exploration, cost of ownership, acquisitions. So you can see the cloud computing technological foundations where the grid computing, it is a form of distributed computing which enables the resources of numerous heterogeneous computers in a network to work on a single complex task at the same time. And grid computing enables parallel computing, although its utility is best for large workloads. Then utility computing, it is a service provisioning model in which a service provider makes computing resources available to the customer as required and changes them for specific uses rather than charge a flat rate. So you can see the word utility is used to make an analogy to other services such as water, electrical, power, etc., that seek to meet fluctuating customer needs and charge for the resources based on the usage rather than on a flat rate basis. Then virtualization. So the conversion of traditional computing environment to what is called a virtualized environment has also accelerated the movement to cloud computing. So virtualizing a computing environment means that the various hardware and the software resources are viewed and managed as a pool, which provides improved utilization of resources. And the objectives of virtualization are to centralize management, optimize resources by over subscription, and use the available computing capacity as efficiency as possible among the users and applications. Then service-oriented architecture, an architectural approach in which applications make use of services available in the network. So each service provides a specific function. For example, a business function such as payroll tax calculation or processing purchase order. So a deployed service-oriented based architecture provides a set of services that can be used in multiple business domains. Then emergence of new IT model, cloud computing. So you can see the cloud computing means it is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, servers, storage, networks, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So you can see, for example, organizations to be competitive in today's this fast-paced, online and highly interconnected global economy. So they must be agile, flexible, and able to respond rapidly to the changing market conditions. So you can see through this cloud computing, an organization can rapidly deploy applications where the underlying technology components can scale up and scale down based on the business requirements. So these are the essential cloud characteristics: on-demand, self-service, broad network access, resource pooling, rapid elasticity, and measure service. Then cloud offering examples. So you can see the organizations might need to rapidly expand their business, which may enforce them to enlarge the IT infrastructure by adding new servers, storage devices, network bandwidth. etc. So critical business data must be protected and should be available to the intended user, which in turn requires data security and disaster recovery infrastructure. So cloud service models, as already discussed, these three service models are there: infrastructure as a service, platform as a service, and software as a service. So in infrastructure as a service, it is the base layer of the cloud stack, and it serves as the foundation for the other two layers, software as a service and platform as a service, for their execution. So the cloud infrastructure such as servers, routers, storage, and other networking components are provided by the infrastructure as a service provider. And you can see the examples of this infrastructure service: Amazon Elastic Compute Cloud, which that provides resizable compute capacity on a pay-per-use basis. It allows customers to hire virtual compute on their run their own applications. Another one is EMC Atoms, which provides online providers storage service like internet accessible on-demand storage. Then platform as a service, it is a platform as a service is the capability provided to the consumer to deploy consumer created or acquired applications on the cloud infrastructure. So platform as a service can broadly be defined as application development environment offered as a service by the cloud provider. So the consumer uses these platforms that typically have integrated development environment, which includes editor, compiler, build and deploy capabilities to develop their applications. Then they deploy the applications on the infrastructure offered by the cloud provider. So platform as a service examples are Google App Engine, which provides the platform for consumers to deploy or create their own applications. Another is Microsoft Azure platform, which provides diverse functionalities to provide to build applications. So these are the platform as a service examples. Then software as a service. This you can see it is the topmost layer of the cloud computing state, and which is directly consumed by the end user. So it is the capability provided to the consumer to use the service provider's applications running on a cloud infrastructure. So it is accessible from various client devices through a thin client interface such as a web browser. So on premise applications are quite expensive and requires high upfront capex, capital expenditure. So they also incur significant administration cost. So the cloud provider will host and manage the required infrastructure and applications to support these activities. So software as a service offers the following advantages. It reduces the need for infrastructure because storage and compute powers can be provided remotely, and it reduces the need for manual updates because software as a service providers can perform those tasks automatically. Then the software as a service examples, you can see EMC, Moji, and Salesforce.com. These are the examples of software as a service on CRM application. Then cloud deployment models. So public cloud, where you can see three deployment models are there: private cloud, public cloud, and hybrid cloud. So in public cloud, the IT resources are made available to the general public or organizations and are owned by the cloud service provider. So the cloud services are accessible to everyone via standard internet connections. Then private cloud, you can see in this in a private cloud, the cloud infrastructure is operated solely for one organization and is not shared with other organizations. So this cloud model offers the greatest level of security and control. So there are two variations to a private cloud: on-premise private data and externally hosted private cloud. So on-premise private cloud is there and externally hosted private cloud is there, where you can deploy this private cloud. Another one is a hybrid cloud, where in hybrid cloud environment, the organization consumes resources from both private and public clouds. So the ability to augment a private cloud with the resources of a public cloud can be utilized to maintain service levels in the face of rapid workload fluctuations. So organizations use their computing resources on a private cloud for normal uses, but access the public cloud for high peak load requirements. So this ensures that a sudden increase in computing requirement is handled gracefully. For example, an organization might use a public cloud service such as Amazon Simple Storage Service for achieving data, but continues to maintain in-house storage for operational consumer data. So hybrid approach allows a business to take advantage of the scalability and cost effectiveness that a public cloud computing environment offers without exposing mission critical applications and data to third party vulnerabilities. Then the community cloud. So this is the fourth one, where the cloud infrastructure is shared by several organizations and support a specific community that has shared concern. For example, mission, security requirement, policy, compliance considerations. So an example where a community cloud could be useful is in a state government setting. So if various agencies within the state government operate under similar guidelines, they could all share the same infrastructure and spread the cost among themselves. So a community cloud may be managed by the organizations or by third party, with the cost spread over to fewer users than a public cloud. And this option is more expensive but may offer a higher level of privacy, security, and or policy compliance. So the community cloud offers organizations access to a vast pool of resources than that in a private cloud. Next one is economics of cloud. So cloud computing has changed the economics of IT. Capital expenditure, which is known as CapEx, is required to build IT infrastructure because organizations hire and use resources from cloud service providers. They will see more of operational expenditure, which is OPEX. So the cloud provides various cost saving options like infrastructure cost, management cost, power and energy cost. So you can see building cloud infrastructures. So where infrastructure should meet essential cloud characteristics. So you can see the journey begins with the understanding the existing physical infrastructure, its elements and processes, and the next step is to focus on aggregating the existing infrastructure resources using virtualization technology. So these resources pools facilitate centralized management of resources and enables faster resource provisioning. Then the core elements of these classic data center are compute, storage, network, application, database management system. So a classic data center, it is a facility that enables IT resources to process this data. So by these elements, core elements, these IT resources are typically viewed and managed as separate entities, but all these elements must work together to address data processing requirement, and other elements of these this classic data center are power supplies and environmental controls such as air conditioning and fire suppression. Then virtualization abstracts physical resources such as compute, storage, and network to function as logical resources. So it creates an abstraction layer to hide the physical characteristics of resources from users. So for example, in compute system virtualization, a physical machine appears as multiple logical machines or virtual machines, each running an operating system concurrently. So this is the virtualize the infrastructure. Then deploy service management tools. So a service management tool enables creation and optimization of cloud services to meet business objectives and to provide value to the consumers. So the services built are listed in a service catalog that allows consumers to choose the desired services. So service management automates service creation and provisioning without any manual intervention. So it also helps the monitoring and metering services in measuring resource usage and charge. So service management tools are also responsible for managing both physical and virtual resources that are used to create cloud services. So examples of management activities are capacity management, configuration management, change management, these etc. can be used. So these management processes enable meeting service assurance and compliance requirements. So the journey to the cloud, a phased approach, you can see. So cloud adoption for an organization is a journey. So organizations have to perform various steps to relate their existing data centers to provide cloud services. So data centers provide centralized digital data processing capabilities required to support an organization business. So a typical data center includes compute, storage, and network, which enable storing and processing large amount of data. So these data centers are also referred as classic data centers. And these in a classic data center, resources are typically dedicated for each of the business units or applications, and this leads to complex management and underutilization of resources. So the limitations of these classic data centers resulted in the emergence of virtualized data centers. So continuous cost pressures on IT and on-demand data processing requirement of business have resulted in the emergence of cloud computing. Then virtualized data center, where you can see virtualization is the first step towards building a cloud infrastructure. So transforming a classic data center into a virtualized data center requires virtualizing the core elements of the data center. A phased approach to virtualize an infrastructure enables a smooth transition from classic data center to virtualized data center. Then compute virtualization. In compute virtualization, a virtualization layer resides between the hardware and virtual machine on which an operating system is run. So the virtualization layer is also known as hypervisor, and the hypervisor provides standard hardware resources, for example, CPU, memory, network, to all the virtual machines. So why we need for compute virtualization? So traditionally, one operating system per compute or physical machine is deployed because the operating system and the hardware are tightly coupled and cannot be separated. So only one application is deployed per compute system to minimize the potential resource conflict. So this causes organizations to purchase new physical machines for every application they deploy, resulting in expensive and inflexible infrastructure. So further, these compute systems remain underutilized. So it is very common to find compute systems running at 15 to 20% utilization. So this compounding over many machines within a classic data center leads to poor utilization of physical machines. So compute virtualization enables to overcome these challenges by allowing multiple operating systems and applications to run on a single physical machine. So this technique significantly reduces acquisition cost and improves the utilization. So hypervisor is a compute virtualization software that enables multiple operating systems to run on a physical machine context. So the hypervisor interacts directly with the physical resources of the x86 based compute systems. So the hypervisor is a key component of data center consolidation efforts. So hypervisor has two key components, kernel and virtual machine monitor, VMA. So a hypervisor kernel provides the same functionality as other operating systems such as process creation, file system management, and process scheduling. And the virtual machine monitor is responsible for actually executing commands on a CPU and performing binary translation. Then virtual machine hardware. So a virtual machine uses virtual hardware. Each guest operating system sees the hardware devices as if they were physical and owned by them. So all virtual machines have standardized hardware, and the standardized hardware makes virtual machines portable across physical machines. Then application virtualization. So application virtualization software is increasing leveraged by organizations to address challenges associated with the application life cycle. So particularly those processes associated with application testing and deployment. So you can see this technology provides the ability to deploy applications without modifying or making any change to the underlying operating system, file system, or registry of the computing platform in which they are deployed. So because virtualized applications run in an isolated environment, so the underlying operating system and other applications are protected from potential interruptions which may be caused due to installation modifications. So you can see the two methods which are commonly used for deploying application virtualization are application streaming and application encapsulation. So application encapsulation package is the application in a self-contained executable package that does not rely on a software installation or underlying operating system for any dependency. And application streaming involves transporting application specific data resources to the client device when the application is executed. So application virtualization benefits, you can see the simplified application deployment retirement. So applications are never installed to an operating system, hence the deployment of the applications is greatly simplified. Furthermore, complex removal of all application bits from a PC during retirement is assured. Then a simplified operating system image management, where because applications are completely separated from the operating system and managing operating system images is simpler. So especially during operating system patches and upgrades, it helps to create a more dynamic desktop environment in which the desktop is an aggregation of separately managed components. Then third one is elimination of resource conflicts, because of each application has its own virtual operating system resources. So resource contention and application conflict issues are eliminated. So this is all from my side. So thank you all the participants. If any questions, I am happy to answer.
Thank you so much, sir. From audience, if you have any question, please ask to sir. Hello. If there is any question? Okay. So thank you so much, sir, for enlightening talk. Now let us welcome our next speaker, Professor Dr. Dinesh Goyal, to continue our journey of learning. Dr. Dinesh Goyal, working as a professor in computer science and engineering department, also working as a CML level 5 certificate accreditation. Sir work as a director, Pune Institute of Engineering and Technology, Jaipur, Rajasthan, India. Sir having different subject expertise. For example, information security, image processing, cloud computing and security, big data analytics, machine learning, and so far. Sir also contribute towards the research in terms of the patent publication, research papers. Apart from that, I just request to Goyal sir to please share your knowledge to our audience. Sir, please, sir.
I think he is unable to connect, ma'am. So we should conclude the session.
Oh. Okay, sir. Okay. So as I conclude this enlightening workshop, I would like to express my heartfelt gratitude to all the speakers for sharing their immense knowledge and expertise with us. I appreciated all the attendant, all the audience for their active participations and the valuable contributions. I hope everyone leaves today with a greater understanding and new year. Just sorry for inconvenience. So thank you for making this workshop successful. Thank you so much to one and all. Thank you. Sorry, 2 minutes.
Thank you, ma'am.
Thank you.
Thank you, sir.
Thank you, Pankaj sir.
Yes, thank you. Thank you to everyone.